In section 1.5, we looked at real-world situations that create a perfectly straight linear line. Sometimes, though, the real-world data is very close to a straight line, but not quite perfectly lined up. If the data points look fairly straight, like they look like they're mostly creating a line, we can still use a linear function to model that data, and we call that line the least squares regression line. Many of the skills we've learned in this chapter can be used with least squares lines. We're going to start with a review from section 1.4 about interpreting the slope and the intercept in context of the situation or scenario. So typically the least squares regression line uses this form, the y equals mx plus b, the slope-intercept form that we're used to, where the slope is represented by the letter m, and then the vertical intercept, so that's often referred to as the y-intercept, is the letter b. And so remember that you do want to keep that sign with both of those. And so our interpretation for the slope is as the x variable, so you'll replace whatever the x variable actually is into this blank. So as the x variable increases by 1 unit, the y variable either increases or decreases. So we would use increases for a positive slope and decreases for a negative slope by whatever the value of the slope is, and then we put the units on there. Yeah, then somewhat similarly, we have the vertical or the y-intercept, and that happens when our x variable is equal to 0. So we're sitting right on the y-axis. So we'll say when our x variable is 0 units, and so we'll replace that with whatever the story is about. Then our y variable is, and then we'll put our intercept value in here with its units. All right, so we're going to look at ice cream sales. So I have an example here. And you can see we have 12 data points here that are plotted on here. We have temperature on the x-axis and we have sales on the y-axis. And so these points are not perfectly straight, but they're really pretty close. And when you fit a line through there, you can really see how they do look pretty linear. Okay, so our story here, the local ice cream shop keeps track of how much ice cream they sell versus the temperature at noon each day. Their figures for the last 12 days are graphed in this graph, and the equation for the line of best fit is y equals 30x minus 159.5. So what I'd like you to do is go ahead and pause the video and give this a try. All right, so let's take a look at these. Hopefully this is a pretty good review from section 1.4. So we're going to start with interpreting the slope. So our x variable here is the temperature, and our y variable is the slope. So that'll help me to fill this sentence in. And so my sentence will be something like, as the temperature increases by 1 degree Celsius, the ice cream sales, or you could just put sales. And our slope here is positive, so we'll use the word increases by $30. So our unit here is dollars, and our slope was 30. So altogether, as the temperature increases by 1 degree Celsius, ice cream sales increase by $30. And then we have the intercept here. So remember, the intercept is when x is equal to 0. So when the temperature is 0 degrees Celsius, ice cream sales are negative $159.50. Okay, so we are going to include that negative sign there. And so that is our sentence. So we're going to come back and take a look at that in the next video as to whether that sentence about the intercept actually makes sense or not.